All right, so we're looking at practice 4, number 4, and it's still a combo circuit. All right, so right here we have 3 resistors. We have, let's see if we can get this to work. Okay, so we have resistor 1, we have resistor 2, and we have resistor 3 over here. Resistor 3 is happening in series with each of these ammeters. Okay, resistor 1 and resistor 2 are going to act in parallel. And so let's go ahead and fill out this table first. Okay, so we have V1 or I1 is going to equal to the voltage drop of 1 over the resistance of 1. So we have 5 volts over 10 ohms, which is going to give us 0.5 amps. This is 0.5 amps. Next, we have resistance 3. And so the current of resistance 3 is happening with voltage over resistance. So we have 12 volts divided by 3 ohms, which is going to give us 4 amps. So this is 4 amps. Now, if we go back and look, resistance 3 has a current of 4 amps. So this is also going to be 4 amps. And what this means is that our total is also 4 amps. Our total is acting in series. Resistor 1 gave us a current of 0.5 amps. So that means that resistor 1's current plus resistor 2 current should give us 4, which means that this is going to be 3.5 amps. All right, so our total is 4 amps, and our voltage drop total is also going to be unknown right now. So what we can do is work backwards. So we'll start with a negative terminal, which will give us 0, and this will give us 0. This will give us 0. So now we're working backwards, and so our voltage drop for the last one is 12. So that means that this had to have dropped all 12. So that means 12, then minus 12 is going to give us 0. So this is 12 also. So every time before that occurrence will just be 12. The only time it will change is if we run into a resistor. So right now I'm working backwards, and this is 3.5 amps because the branch of 1 plus the branch of 2 will give us our total right here. And the voltage drop for 1 is 5. So something minus 5 gives us 12. And if we go backwards, it'll be 12 plus 5, which will give us 17. And that means that everything in this row right here will also be 17 because there's no resistor making it change otherwise. And so that means our total will also be 17. All right, so our total is 17 volts, we found out. And the bottom parallel also has a 5-volt drop. Now all we're going to do is just do algebra to figure out the rest of it. So let's start with our total. Our total resistance is equal to our total voltage over our total current, which is 17 volts over 4A. So we have 17 divided by 4, which is going to give us 4.25 ohms. So this is 4.25 ohms, then 5. So we'll do the same thing for resistance 2. 5 divided by 3.5 is going to give us about 1.43 amps. And so let's go ahead and fill out our schematic. In our schematic, let's draw it in gray this time maybe. We have our battery, and then we have an ammeter right after the battery, and then this is where it branches. So we have the top resistor, resistor 1, an ammeter, resistor 2, an ammeter, okay, and then it goes around, and then it runs into another ammeter, and then a resistor, then an ammeter, whoops, okay, I accidentally erased everything. So a resistor, then an ammeter, and the wire around. And we'll just fill in the ammeters with what we do know. So our totals were all 4 amps. So inside will be 4 amps. And our top one was 0.5, and our bottom one was 3.5. And then we will label our letters. Remember that we're going to label them before and after. So I'm going to label before and after. So this will be C, C prime, D, D prime, and then maybe here for E, and then we can do F and G. Remember that the letter choices are kind of arbitrary, so don't worry too much if it's super exactly the same as mine. It just needs to be close enough so that we can tell that you were working on it. Okay, so now we're going to label. We have A, B, C, D, E, F, G, and then back to A. And I think our highest voltage is going to be 17, so we're gonna just go by 5s again. All right. Let's start with a pink. So we have 0 at A, and at B we get to 17, so it's about here. C's at 17, and then D doesn't lose everything, it just goes down to 12. Right? And then E is also going to be at 12. F is also going to be at 12. And then at G, that's when it goes all the way down to 0. So then our graph will look something like this. And if you remember in class, we talked about the prime branch. So we'll just draw another color, the blue for the prime. And then to fill out the power is equal to I times V. So we'll do that in a different color so you can see it better. And for the first one will be 17. Let me see if I can. Okay. So this will be 17 times 4 will give us 68 watts. Then here we'll have 5 times 0.5, which should give us 2.5 watts. We have 5 times 3.5, which will give us 17.5 watts, and then 12 times 4, which will give us 48 watts. And then for brightness, we just ignore the total and order it from least to greatest. So we have least, and then the second least, and then the greatest. So that's how you would do practice 4, number 4.